Hi all, here's an example of a correlation and regression problem. So here we have 9 houses and we know the size of the house in hundreds of square feet and the monthly rent for each. So for the first observation, this means that a house with 1,200 square feet has a monthly rent of $875 a month. Um, and they want us to construct a scatter plot for the first part using size of the house as the independent variable since we want the size to predict the rent. And they also want us to calculate and interpret the sample correlation. Um, they want us to test if there's a linear relationship between the two variables. And we want the regression equation. And then using that equation, we want to predict the rent of a house that is 1,100 square feet, which we need to be careful with the units because 1,100 square feet just means that x equals 11 or the size equals 11. So let's go ahead and copy and paste the data into StatCrunch. So copy it, go over to StatCrunch, paste it, and I'm gonna label the variables in this case so we know which one it is. So this is size, and this is going to be rent. So we go to Stat, Regression, Simple Linear. Our x variable is going to be size. Our y variable is rent. And then we have a hypothesis test for the slope. Remember that slope is the same thing as testing the correlation. So we have our slope equals 0 versus slope is not equal to 0. And then for our prediction value, we can just go ahead and put 11 in here. That's for part 5. And for the plot, we want our fitted line plot. And then we go ahead and push compute equals. So we put compute. So it gave us our output. Okay, so here's the part, the last part. But let's go ahead and copy. We can copy it all. So Control C. I'm just going to paste it right here for right now. And then let's go back to copy the correlation plot. Copy. It tells you directions down here. Sometimes it can be tricky. So we right click and select copy image. To paste in a word, we do Control Alt V. And each computer might be different. So Control Alt V. And device independent bitmap. So I pasted that underneath the first question where it says construct a scatter plot of this data. And then if we look at the plot, we can see that there appears to be an increasing trend. The and linear because the points, the data points, are very close to the line. They're not too far off. But for part 2, it asked to calculate and interpret the sample correlation. So let's go back up to the output, and we're going to copy the correlation coefficient. It even tells you. So correlation coefficient, we copy that, and we just paste it. And don't forget to interpret this. And this is a positive correlation since it's a positive number and not a negative number. This is positive, not negative. And this is very close to 1. So we will say it's a strong positive linear relationship. That's what this is. So that's how you would describe this. So then for number 2, we test to determine if there's a linear relationship. Now we know in the data that there's a strong linear relationship, but from number 2, but the question with the hypothesis test is that can we determine that there is a linear relationship in the population? So we need our hypotheses. So that's going to be just like insert the equation. H naught is going to be rho equal to 0. And then let me just copy this again. And then the alternative is going to be not equal to 0. So not equal to 0. So now we need the test statistic. So that's in our output. That is under slope. So we get our slope and the test statistic is here. And our p-value is less than 0.0001. So this is our test statistic. So t equals is that, and our p-value is less than 0.001. So remember, we reject H naught if p-value is less than 0.05. That's our alpha level. So in this case, we know that our p-value is less than 0.05. It's less than 0.0001, so that's very small. So we reject H naught. There is sufficient evidence to conclude a linear relationship between size and monthly rent. Okay, so that's that for number 3. Number 4 says state the regression equation. So going back up to our output, our regression equation is just right here. So copy that. Put that underneath the regression equation. So that's just our regression equation. And I'm going to copy it again for number 5. Number 5, we just say, use this equation to predict the rent of a house that is 1,100 square feet. So remember I said that size equals 11. So instead of size in this, I'll replace size by 11. And that is going to be, let's get our calculator. So we have 4, times 11. So we have 797.78 cents. 797 and 80, what did I say? And 78 cents. And this is money. So that's saying we predict a house with 1,100 square feet would have a monthly rent of $797.78. And I just plugged this into the calculator, but remember I did it out in the StatCrunch. So this is actually where you would get your answer as well. So that's it. If you have any questions, let me know.